This comment is from one of my previous NestJS tutorials, and it says, please can you make a video on how to integrate payment method like Paystack, Flutterwave, etc. So I am making this tutorial for the person that dropped the comment and every other person that is interested in learning how to integrate payments in their web applications. For this example, we are going to use Paystack, but be rest assured that most of the things we are going to learn will apply to other payment providers integrations. So let's get started. I will be taking a different approach in this tutorial. Instead of writing the code and explaining it along the way, I want to focus on explaining the implementation. Because of this, I already have the code that integrates Paystack, but I will explain every step. Starting with the very basic things, let's understand this controller, transactions controller. This controller has a few endpoints. The first one is to initialize transaction. This is the point that the user begins their payment journey. At this point, what will happen is that we are going to call Paystack. You will see in the actual implementation, the controller is a bit dumb. It just calls the initialize transaction from transaction service. So this is going to initialize the transaction. And then we have endpoint for verify transaction. This slash transaction slash callback. This is a common term in payment where we get callback from the payment provider and we verify transaction using the information in that callback. Again, this method is straightforward because it just calls the service. In fact, the service method is where we have the main thing. Moving on to the next one, we have this webhook endpoint. This endpoint is for another common thing in payment. This is for server-to-server communication between our application and the payment provider. So there will be no user interaction in this communication for webhook. Paystack is going to call this endpoint to notify us about payment, whether it is a successful payment or refund or whatever that happens. Paystack is going to call this endpoint. And again, in the controller, we are not doing anything. We just call the handle Paystack webhook and the logic is there. The implementation is there. But there are a few other things you have to note about this controller. It will become clear during the demonstration. So here we say HTTP code, HTTP status, okay. That is because by default, webhook endpoint expects that we respond with 200 status code. But in NestJS, when you call a post endpoint, it's going to respond with 201. So I'm just telling it, in this case, I want you to respond to the payment provider with status code 200. And then here, we have a regular stuff, which is just to get the request body from whatever Paystack is going to send. And here, similar to the way we access the body, we can access the headers. So in the header, Paystack is going to send a special header named this. And this header is going to contain some hashed data, which we are going to see how we are going to compute our own hash and validate, compare with the hash that Paystack is going to send. If everything is okay, Paystack will quickly get a 200 response status. If not, we just throw a bad request exception so that Paystack knows that it didn't go well. And finally, this guy here is just for me to, I just want to list all the transactions in my database. So I'm going to call all these endpoints in a moment, but let's move on to the next simple stuff. The next simple thing is something that I'm thinking it's not really necessary. I could have just had coded some data for this demonstration, but let me show you since I already have it. I have two tables, products and transactions. In products, I put whatever field I want to put there. So this is not like a standard or a rule that your products table must have these three guys. I have the ID, I have product ID, and I have the price, which is stored as an integer. Take note of the price, it is going to be in cents, or in our own case, since it's Paystack, in Kobo. So this is going to be the amount plus the cents plus the Kobo part of it. For example, if the price of the thing is 99, instead of 99 we say 99.00, because the last two is like this decimal. This is a standard that is also common. If you prefer to treat it in a different way, that's up to you. You can do the conversion between API calls between your application and the provider, but it might be simple and straightforward to just store in the format that the provider expects. I did not choose to store in cents or Kobo, whatever you prefer, but because that is the standard API expects. And for the transactions, I have the primary ID column once again, transaction reference. I will be getting some most of this information from Paystack, and I want to have some of those information in my database, these three, for example. And this is just for something I choose to have here as well. I want to keep it simple. A payment status is either paid or not paid. So this is an enum payment status. And then product ID is just a replica of the product ID as we have here. This is my own structure. Your table can have whatever you want your table to have. This is not really important. Now let's look at another simple thing before we go to the main implementation, the DTO. So as you already know, I guess, DTOs are just representation of the data we pass around in our application. For example, the DTO for initialize transaction, I'm expecting only the product ID to be in the request data. I don't have validations here. I want to keep things simple and just go straight to the main topic. You can add validations and do all those usual stuff you used to do. And for Paystack DTO, these are just representations of what I got from Paystack documentation. For example, to call Paystack API, they expect not random data, but data that follows their own specifications. For example, to initialize transaction, it expects that there should be amount in cents or Kobo, anyone you prefer. There should be email, and then there should be optional fields like callback URL. We're going to see what all this represent. A metadata field. This metadata, these are the fields I have in my own metadata, and custom fields, which are also, these are also free fields. You can store whatever you want to store there, something that makes sense for the transaction. We are going to see an example what I chose to store in as custom fields. And this other DTO Paystack create transaction. So when we initialize a transaction, we get a response from Paystack, and this is the shape of that response. I just pick the fields that I'm interested in most of these. Okay, there are other fields that Paystack expects as optional field or sends among the data that they send, but I'm not really interested in those things. I just pick what I need. And then this is for verifying a transaction. We have this controller for callback, and when we get the thing called callback, we want to verify transaction in the implementation we are going to see. So this is the shape of the data we are going to send to Paystack for verifying transaction as they expect it to be. And then we have the thing we call Webhook, the server to server communication thing. And this is the shape of the data that Paystack will send to us when they send that webhook. So this data is broken down here. By the way, I don't need most of these fields. Should have just removed. I think I used only the first few, like 3 of them, but I'll leave it there. And then I have Paystack callback DTO. This is the data, this query param here, callback, and this query param. This is data that Paystack is going to send for callback. Remember, we have the other one is for response to initialize transaction. We have this one for callback, and we have the other one for webhook. And finally, this is just my thing. I want to mark a payment, a transaction, as either paid or not paid, keeping it simple. And that's all for the DTO. And I think we have covered all the basic stuff. One last thing is this. Okay, I'll get to this as we use them, but these are just global constants. You don't really need to. These are just global constants. Let me leave it there. So now we can go into the main implementation and look at them one after the other. Now let's take a look at the first step among these transaction service methods, and that is to initialize transaction. This is the first step when the customer wants to pay. And what does it look like? I will go into the code. Before that, let's see the documentation. So we initialize transaction from the backend. That's what this is saying, and that makes sense. And these are some of those fields I was talking about. The data that you have to, these are the required data, and this is the structure of the response. But what does this mean to initialize transaction? We are just going to call Paystack API and say we want to initialize a transaction for this customer and this amount. And along with that, we can supply other fields. These are the required fields, and these are the optional fields. Okay. In my own case, in the initialize transaction, it takes the DTO, initialize transaction DTO. From there, I am extracting the only field there, which is the product ID. And then I find the product from my database. These are not really why we're here. I could have just hard coded the product as well, just like I had coded the user here. But let's continue. I find the product and I find the user, or I had coded the user to demonstrate. And then I prepare the payload that Paystack is expecting. And what is the payload? The same payload that is described as body parameters here. It requires email, amount, and other fields which are optional. And which other fields are there? I chose to pass metadata. Among all there are various other fields, but I just chose to pass metadata, so you can see there. So in my own metadata, I just have some things that make sense to my transaction. You can pass whatever you want to pass, and all these are just for demonstration. So here I'm passing the user ID, product, and the customer name, customer email, favorite color, discount, whatever you want to pass here. At the end of the day, you are going to get those information back, or when you are checking the transactions, you can see this information. As you are going to see, take note that this part will appear in the email that Paystack will send. So you be careful what you are passing here, whether you want the person that will get that email to have access to those information. We are going to see that as well. So at this point, I have the payload that I want to send to Paystack from the backend, not from the client side. And then we come to what is called callback URL. Callback URL refers to the full URL that Paystack will have to call when customer has been redirected to Paystack to make payment. And after that, where does the customer go from that point? If, for example, customer has made payment and is successful, what happens next? So Paystack will call this endpoint with some data, with some information. It's just a GET request. And when Paystack does that, we verify that transaction. So I'm telling Paystack we are going to use this Paystack callback URL. By the way, before we go further, let me explain some environment variables that are necessary for this implementation. For my callback URL, I have this as a placeholder. So in your own case, you are going to replace, let's say example.com, your website.com /transactions, which refers to this slash, not really. I made a mistake here. It should be callback. This should be callback, not webhook. So transactions / callback should be for the callback URL. And the next one is Paystack public key. If you're already using Paystack, or even if you don't, go to Paystack and create an account and go to the settings. You are going to see your own public key and secret key. Of course, make sure to keep those things secret and don't commit it to Git or whatever you are using. So you copy and paste your own public key and secret key from Paystack. And that's just all the things we need here. Now back to initialize transaction, back to where we stopped. I'll come down here. What happens is that on Paystack, the settings page, you can specify a callback URL. That becomes the default callback URL. So if you don't specify any callback URL in your code or in your request, not necessarily your code, in this request, if you don't specify callback URL, that default will be used. So this is not really necessary, but I just want to demonstrate to you that you can overwrite that default that was specified in Paystack settings page. That's what the thing is for. And then coming down here, this is just the request body. You can call it payload, you can call it params. Let me just call it payload so it doesn't sound like query parameters, because this is a post request. So JSON.stringify the data. By the way, I'm stringifying because that's how Paystack wants it. Otherwise, I would have just passed this Paystack create transaction details straight to here. And then we send the request. I have a try catch here because I am calling an external service, and I can guarantee, it's outside my control to guarantee that this external service will not throw any exception. If it throws an exception, I want to cache and handle that. So we call Paystack endpoint here according to the API specifications, and it requires us to call this URL api/paystack.co and whatever with the payload that is a string, hence the JSON stringify, and the headers. So this header is required, the bearer token. This bearer token is your Paystack secret key, which is the thing you are going to put in your secret place. And then content type, I don't know, can't remember if this was really required. Maybe it was required, hence me putting it there. So when we call that API, we get a result, and this is just an Axios stuff. We grab the data from that result. The shape of the data that Paystack will return is already there in their documentation. So if I go to the documentation, when we initialize transaction, we get this kind of response, and that is what I have here. I have status message data. So when I get that response, what you will notice is that this authorization URL is a payment link. As we are going to see in the demonstration, is a link that you can automatically redirect the customer to make payment However you want to use the link is up to you. And down here, I want to check because it will also return a status. Let's take a look here again. So there will be a status field that is a boolean to status just whether the request went fine. And what I'm doing after that is to create a transaction record in my database. At this point, this transaction is not paid yet. Nothing has happened. I just initialized. So in my database, the status is going to be the default, not paid. And the transaction status, this one from the provider, is going to be null at the moment and all that. So this is for initialize transaction. We are going to try it out before we see the next steps. One thing I forgot to mention is about the callback URL. When you go to Paystack to set a callback URL for your application, you will notice that you cannot use HTTP like localhost URL. It must be HTTPS. But I'm in a local host environment and an application is not running in HTTPS. Because of this, I'm using a service application, what do I call it, that is called NGRock. With NGRock, you can map your localhost URL to an HTTPS URL for free. So what that means is that if someone calls this URL, for example, localhost 3000, or calls this one, they are calling the same application. So this is a different thing altogether. If your application is running with HTTPS, you don't have to do all this, but because, like I said, this is a local environment and I must satisfy the requirement that whatever URL I enter at Paystack, whether it is callback URL or webhook URL, as we're going to see, must be HTTPS. So I'm using this for that. Now, let me go ahead and call the initialize transaction endpoint. By the way, I already have my Paystack public key in .env and my Paystack secret in .env. I don't have to show you that. And this .env.template is that when you get to your own code, you can use this as an example and place your own values there. Let me start the application in debug mode. In my database, I already entered two products. One is makeup tutorials, the other one is baking lesson, whatever. Over to Postman, I'm going to call the initialize transaction endpoint with the product ID. So when I send this request, I put some breakpoints here so that we can see the data we got from Paystack. So what has happened is that this endpoint was called with that payload, and in the initialize transaction, a request has been sent to Paystack, like I already explained, and we got a response. But what is inside that response? Inside the response, you can see that we have this data like we saw in the documentation: authorization URL, access code, reference, payment reference, whatever, all this. But what I need for now is this URL. So I will let this continue and I will go back to Postman. Here you can see that we got the result because we created a transaction in our database and returned it. To see that, if I have this find transactions, you can see this is what we have in the database. So we initialize a transaction. If it is your front-end application that got this link, you might want to automatically redirect the user to this URL so they can make payment. But I'll visit the link manually from here. Now, so this is going to take me to Paystack to make payment. But because this is a testing environment, just to simulate whatever you want to simulate, whatever payment channel that you want to use, I'm going to use card payment. But before we make payment, let's ask ourselves what happens the moment I make this payment. The moment I make payment, the callback URL will come into play. So let's understand the callback URL before making this payment. Let me remove this and stop the debug. Now we talked about callback URL. We say that after payment action, whether successful, whatever, I don't care. What happens is that Paystack is going to call our callback URL. And what it basically does is to send us the transaction reference, and I think one other parameter which I'm not interested in. It's going to send us the transaction reference in a field called reference. With this transaction reference, what we want to do is to call Paystack again to verify that transaction. To verify means to check, for example, what is the status? Was it successful? What other information? And that is what this implementation is about. Before going through the code for verified transaction, let's look at the documentation. So we call the endpoint to verify transaction, and what do we pass there? The reference field that Paystack will send as callback. We already have this reference, by the way. We have it in our database already, but Paystack will still send it. If you look here, we have this transaction reference. When we call the verified transaction endpoint, we get a response, something similar to this. But once again, I only picked some fields that I'm interested in for this demonstration. So back to the code, what are we doing here? First, we find that transaction from our database using the reference. Remember, we had that reference when we initialized transaction. Every other logic is up to you what you do if you don't find that transaction. So let's leave this guy and go down. The transaction is found. Then the next thing I want to do is to prepare the request to send to Paystack. We have to call the verified transaction URL we just saw in the documentation, passing the reference as a path param. So this is the URL. And then I'm using Axios for my HTTP request. I will send request to that URL and pass this header. This is according to the API specification. I'm supposed to once again pass the Paystack secret key as a bearer token. And when I do that, I will get the response we just saw in the documentation. But I am picking only the fields that I'm interested in. And these are the fields that I am picking among all those information. With that data, I want to check if the payment was confirmed, if it was successful. So in the response data, there's going to be a status field. Let me show you once again. There is this status field. So if it is success, then we know that the payment was successful. That is what I am checking here. If it was success, the string success. If it's success, I want to set this transaction status to paid. Any other thing, not paid. I want to keep it that simple. And then at this point, I want to populate this transaction status field that I said is the one from Paystack. And finally, I will update that transaction record in the database. So let's make the payment and see what happens here. Let me launch the application again. And this endpoint will be called by Paystack when we make payment. So I'll go ahead to pay. I want to initialize another transaction. I noticed that the callback URL I entered was not correct. That is my own callback URL that I entered on Paystack. So I will leave the first one and initialize another transaction. I'll just send the same request like before. And then I will copy this and visit the URL. So this is another transaction. You will notice that the amount I entered in database was 123400, but because it is in cents or in kobo, this is what that results to. Before I make this payment, let me show you my Paystack setup. This is the settings page I was referring to. I had to hide my public key, and this is the callback URL I was talking about. And this is another thing we call Webhook. This is for the other endpoint that we are going to talk about, but this is how just the URL to that endpoint in our code base, this very one right here, this webhook. So when I make payment, Paystack is going to call this callback URL with an information. But let me go ahead and make the payment and pay. The payment was successful, and watch what happens. We are brought to VS Code because when you add this breakpoint, automatically when the code execution gets to that point, VS Code will open. But if I go to the browser, you will see that this is hanging. It is hanging. It's called our endpoint, the callback URL, but hanging for the code execution to continue. I put this breakpoint here because I want to show you the data that Paystack sent as part of the callback. It just sent the reference and this other thing that I'm not using. Oh, interesting, it's the same value. So this is the reference, this is transaction reference. And so let me go to the code and continue the execution. Now I will go back to the browser and you can see that the endpoint was called. This is /transaction/callback transaction reference and reference. So if I go back now and check the status of that transaction, this was the transaction when we created and returned it. The status was not paid and the status, there was nothing there. But if I let me go here, the ID is 2, so let me fetch all the transactions. For ID 2, you can see that the status we updated in our code to paid, and this is the status we got from the payment provider, from Paystack. So this is the steps we have applied for verifying transaction, and we are applying this verified transaction for this callback. You can use it for other purposes. Maybe you want to expose another endpoint. You can have a form or somewhere in the front end where someone can input transaction reference and verify that transaction and get the information about it. Now let's move on to the next thing, which is Webhook. I talked a little bit about Webhook. We say it is for server-to-server communication between our own application and Paystack. So basically what happens is that when the payment is made, Paystack is going to call this endpoint. For callback, is going to redirect to this callback URL. This is really helpful, especially for a case where this callback has an issue or you don't really want to have this callback at all. There could be other reasons, but let's go to the implementation to see what happens here. So what happens here is that Paystack is going to call the endpoint we specify as the webhook URL, and when that happens, Paystack is going to send some payload. Once again, I picked the fields that I'm interested in from that payload, and a header, a kind of special header. This header is called X Paystack signature. Other payment providers might name their own header whatever they want if they use it. So we need those two information in this service method. called handle Paystack webhook. Here we want to validate to be sure that this webhook request came from Paystack. Otherwise, if you go ahead to trust anything that calls your webhook endpoint, by the way, note that this is usually a public endpoint, so there's no authentication or anything protecting the endpoint. And talking about authentication, I decided to leave that out from what we are doing here, so we can just focus on payment method integration. So a request comes into the webhook. We want to check that it is authentic, and how we do that is this usually come in form of hashed data. There is going to be the plain data. In the case of this Paystack, there is a plain data, that is this DTO, and then there is a hashed equivalence of that data. So you can take a look on what is hashing and how it works and all that. It's not our focus here, but this same payload is hashed, and that hash is contained in the header, and that header is what we grabbed here. We are going to see what that looks like. So let me add some breakpoint for that. I'm going to add one here so you'll see what those things look like, and let me add another one for here. So when we get the data and the hash, what we are going to do is to use our Paystack secret and compute the same hash. The hash in question is a hash of this of the data, this DTO. So what happens is that Paystack, we use the secret key to create and send the hash. So this DTO is hashed and sent as a header. Then in our own code, we are going to do exactly the same thing. We create the hash of that DTO, hash of the same data, that is the DTO. And when we create it, if everything is okay, they will give us the same value. So we compare that value. So let's say, for example, this hash, after the whole hashing was done, gave us something like this. That is the hash. When we create the same hash, when we hash the same data with the same key, we are going to get exactly the same thing. If there's any difference, we are not going to get the same hash. I don't know if you get the point, but that is it. So we create our own hash like this, and then we compare that the two hash match. How do we create the hash? We use this create hash mark that is from crypto Node.js package. Come on. So we create the hash like this using our secret key, and then we do comparison in a way that makes what is called timing attack more challenging. So instead of a simple equal to, instead of simply saying hash equals to signature, something like this, hash, instead of checking whether hash equals a signature, we use this timing safe equals, which is also from the crypto package. But this is left for the security expert to tell whether just doing it like this is okay. But what does this do? Let's see. It said that this function compares the underlying blah 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 in a way that makes it more difficult for timing attack. You can read the documentation. That's what this thing is trying to do. That's why we are not using a simple equality comparison, and we do everything at a go. So when we check and we have seen that this hash that Paystack sent us matches the hash we computed with the same exact data and the secret key. If that is true, we can say that this event or this webhook request came from Paystack. Otherwise, we say it didn't come from Paystack. Okay, we don't trust it. But if you want to be a little extra careful after all this, you can utilize our verified transaction implementation. We already have a method to verify transaction. And what does it take? It just takes the payment reference. So this webhook is going to send a data that contains the payment reference. Inside this data, there's going to be the reference. So you can grab that payment reference if you don't trust your hash verification and use it to call the verified transaction to retrieve that data straight from the provider. We have verified that this webhook request came from Paystack, and we can trust that data, do with it whatever we want to do. And what did I choose to do? I found the transaction for that payment reference, and I updated the transaction status where transaction status and set the status to paid if the transaction status is success. Otherwise, set it to not paid, and that is just it. So there's a whole lot on how webhook works and hashing and all those things, but you can take your time to research and read more in depth. What we're going to do now is to give this webhook thing a try. Although we can have both callback URL and webhook working, I just want to demonstrate the webhook only so that it doesn't confuse us whether it was through the callback URL that we got the payment status and updated the records in our database. Because of this, I'm going to remove this callback URL and save the changes. I will also remove from my .env the overwriting I talked about callback URL. And let me go to Postman and initialize another transaction. So I'll send the request. We have a new transaction. This is the ID number 3, and this is the payment link. I'll go to the payment link to make payment. By the way, before I make this payment, let me show you the thing we talked about, the request we send when we are initializing transactions. I've made two payments, and for the first one, you can see some of those, the metadata fields that we send. For example, favorite color is in the email that I got from Paystack. The discount, the email, the name, those information I passed there. The same thing applies to this second payment. So let me go ahead and make this payment. Before I make the payment, let's confirm the status from the database. So the status for this guy with ID 3 is not paid, and there's no transaction status there as well. Then make the payment. Payment is successful. You can see that once again, because there was a request, the webhook request came in, the VS Code automatically launched. And if I go to the browser, there is no redirect because we did not specify the callback URL. So we got this webhook, and let's see what is inside there. In this webhook, we have the signature we talked about, which is a hash of the data, this thing I called DTO. This signature is a hash of the data, and this is the one that came from the payment provider. And what we do from this point is to compute, to create the hash and compare. And that is what I've already explained here. So we continue this execution. We have computed our own hash, and this is it here, our own hash here. No, that should be up here. So when you look at these two things, you can see that they are equal. Okay, this is the hash we computed. This is the hash from the provider that is called signature. The key is signature. Because they are equal, we can say that this event, this webhook request, came from Paystack, and we proceed with processing that information further. So let me continue this, and the request is done. There is no user interaction in the sense that Paystack can decide to send this webhook in the next 5 minutes, in the next 1 minute, whatever, it doesn't necessarily mean that the user has to wait for the webhooks to happen. It doesn't concern the user that made this payment. So let's look further into this webhook thing to understand the hashing a little better. I will go back to Postman. What I want to do is to simulate a case whereby someone just sends some random stuff to the webhook endpoint. This is the webhook endpoint. I'm using localhost 3000 because this is me calling the endpoint. Otherwise, I'll have to use, on the provider side, we used HTTPS and the ngrok URL stuff. So I'll send this request, and this is trying to mimic the Paystack header, and this is trying to send some fake hash. I'll send the request, and we cache that in our breakpoint again, and you can see this is the data, this is the reference. Where is the hash? Yeah, this is the hash that I sent. Now when the hash is compared, you will notice that they are not the same thing. So let me continue this execution. You can see that this is my hash that is computed using the payload that I sent and the secret key. But this is the hash that was computed using a wrong secret key. So they are not the same, and we cannot trust this webhook. Okay guys, this brings us to the end of this lesson on how you can integrate payment methods in your web application. Please note that this is not really like the way you must do it, but just to give you an idea, you definitely want to be sure that everything is implemented and properly tested and safe and secure for a production application. I hope this makes sense. Until next time, enjoy coding.